Hi, Dr. Erickson. This is Dr. James Beadle. I was talking with Chuck, and he wanted me to make a quick video on how your tool works for the CSL, or was the orthospinology central skull line. Anyways, just to give you a little background real quick, the reason why Chuck asked me is because I'm one of the directors or board members of EPIC, the branch off that happened from AO to Advanced Orthogonal to now EPIC, with Stan Pierce Jr. Anyways, I've been making several updates and recognizing a few mathematical errors that 2020 had, and I've been working with Chuck and their programmers to actually fix quite a few of these errors, and because of that, I've learned quite a bit of these different tools and what are they trying to actually do and what are they actually mathematically actually achieving. So um, that's why he asked me to do that. So my pleasure. I'm excited to be able to talk with you. You're one of my big heroes actually in the chiropractic realm, and I just want to say thank you for all that you've done for all of chiropractic, especially upper cervical. So anyways, to dive into the mathematical reasons of how your tool works, it's actually quite simple. I thought it was due to a few different things, but it's actually even easier than what I originally thought. So the first thing is it's not comparing uh, pixel to pixel on both sides. So I thought it would say, okay, what's the point here, and what's the point here, and then average it out and create this center line right in the middle. What it's actually doing even easier than that. What is going on is it will compare obviously the contrast between the dark to the white for the skull, and we'll do that on both sides, and then it will plot tons of dots along through here, which will then create an average slope. That's all it's doing. It's just taking all these points and what's the trend line essentially, what's the slope of all those points, and then it will compare that to all the points over here and create that slope line. That's why you're seeing these lines coming all the way down this direction, because that's the average slope that it's creating with that contrast. Then mathematically extremely simple. It's taking this slope line minus this slope line, and then that creates the difference. So let's say this is, I'll go ahead and type this in. If this was a slope of 2 and this was a slope of -2, when you add those together, that creates a slope of 0, and that would be a perfect central skull line, right? Where it just goes, absolutely vertical, kind of like that, right? Um, and obviously that's not the case for this patient, but just as the example of what we're looking at. So if this was instead a 3 and that stayed at a -2, well, now we're looking at an angle instead of a 0. We're looking at 1. Let's go ahead and throw up an actual line here of 1 degree, about right there, like this. So you can see how it says 89, but it's 1 degree tilted off that direction because of the math. So that's the mathematical reasoning. You can click on here and you can actually zoom in and see what some of the angles are. So like this is actually showing that the average of the two angles, or the summation of the two angles, is 88.45, and they're using 256 points. And unfortunately, you can't alter any of this. This is just all automatic. It would be kind of interesting to be able to actually alter that, but it's just not allowed. So, so that's the threshold, and I'm guessing resistance. They have not told me what this is right here. Um, Pros and cons of this is, one pro, you're looking at multiple points, getting a really good average of the slope of the skull, um, and it's just extremely fast to be able to use. For that, I absolutely love it. There's a few cons though. The con is, well, actually, another pro just to show you. you can see how like with this patient, they have some dents in the skull, and using the old template, which is this guy, right? This is the one that we've used before. Uh, that doesn't allow you to actually look for dents in the skull. You have to do this two zoning procedure and such. But with your template, your tool, it actually makes it to where we don't have to do that, which is great. I absolutely love that. But the con that we're seeing is that if the patient's head is tilted, then we have a problem. So I'm going to pull up a patient that I have, and the other one was just like a demo one. So let's make this full screen. Here we go. So here's a patient that I have. This just happened this past week, actually. And I want to show you the difference between using the template that we have, this one, versus the orthospinality tool. And this is one of the things that we're trying to get 2020 to be able to change, is that this line right here is from our template that we created, or not we created, but that we use, right? This one right here. You can see you just tilt it to match the skull and do that. We created that line. Okay, I'm not going to show that process because you already know that. But there is a difference between that line and this one that this tool created. And the reason being is all about frame of reference, right? So we're trying to stay above the suture lines, right? But because the head is tilted, and we don't want to remove that tilt because that's part of the the whole process for Grostic, is that we're getting really close to the suture line here, but over here there's a big gap. So instead of being able to tilt the tool and actually stay along that line so that you're actually measuring the same area left to right, something like this. So this would be the actual box you'd want to use. I'm going to move that out of the way. So you want to be able to rotate that tool so that now you're actually measuring an inch or inch and a half on the left and an inch to inch and a half on the right, so that you can actually do the real Grostic zoning procedure. And because you cannot rotate it, this tool only works for people who don't have head tilt. Otherwise, you're getting this discrepancy right here, which adds to 1, 2, 3 degrees, and that completely changes that upper angle. So because of that, we haven't been able to fully just convert to using this tool, and that's why we need it to be rotated to be able to get a more accurate zoning procedure for the upper angle. Anyways, if you have any questions about this, I'd be happy to answer you. I'll send you my contact information on the email, and look forward to communicating with you more about it and hopefully making it even better.